The first record. This book is organized into a sequence of chapters with various topics on concurrent programming. The book covers the fundamental concurrent APIs that are a part of the Scala runtime, introduces more complex concurrency primitives, and gives an extensive overview of high-level concurrency abstractions. Chapter 1: Introduction explains the need of concurrent programming and gives some philosophical background. At the same time, it covers the basics of the Scala programming language that are required for understanding the rest of this book. Chapter 2: Concurrent on the JVM and the Java memory model teach you the basics of concurrent programming. This chapter will teach you how to use threads, how to rotate access to shared memory, and introduce the Java memory model. Chapter 3: Traditional building blocks of concurrency presents classic concurrency unities such as thread pools, automatic variable, and concurrent collections, with a particular focus on the interaction with the features of the Scala language. The emphasis in this book is on the model, high-level concurrent programming frameworks. Consequently, this chapter presents an overview of traditional concurrent programming techniques, but it does not aim to be extensive. Chapter 4: Asynchronous programming with features and promise. This is the first chapter that deals with a Scala-specific concurrency framework. This chapter represents the features and promise API and shows how to correctly use them when implementing asynchronous programs. Chapter 5: Data Parallel Collections describes the Scala parallel collection framework. In this chapter, you will learn how to parallelize collection operations, then it is allowed to parallelize them, and how to assess the performance benefit of doing so. Chapter 6: Concurrent Programming with Reactive Extensions teaches you how to use the reactive extension framework for event-based and asynchronous programming. You will see how the operations on event stream correspond to collection operation, how to pass events from one thread to another, and how to design a reactive user interface using event streams. Chapter 7: Software Transactional Memory introduces Scala STM library for transaction programming, which aims to provide a safer, more intuitive shared memory programming model. In this chapter, you will learn how to rotate access to shared data using scalable memory transactions. At the same time, reduce the risk of deadlock and race condition. Chapter 8: Actors represent the actor programming model and ACA framework. This chapter you will learn how to transparently build message passing distributed programs that run on multiple machines. Chapter 9: Concurrency in Practice summarizes the different concurrency libraries introduced in the earlier chapters. In this chapter, you will learn how to choose the correct concurrency abstraction to solve a given problem, and how to combine different concurrency abstractions together when designing larger concurrent applications. While we recommend that you read the chapters in the order of which they appear, this is not strictly necessary. You are well acquainted with the content of Chapter 2, concurrency on the GVM and the Java memory model. You can study most of the other chapters directly. The only chapter that heavily relies on the content of all the preceding chapters is Chapter 9, the concurrency in practice, where we present a partial overview of the topic in this book.